Okay, so now what we're going to do is look at finding the second derivative implicitly. Of course, if you remember, this was a notation we had discussed earlier that represents second derivative. So, of course, we got to get first derivative. So going through the steps, same as we did a while ago. Take the derivative of this implicitly. So this would be 2x plus 2y dy dx. Of course, derivative of a constant is 0. Okay, you do want to get dy dx by itself. Okay, so then you need to divide by 2y. So you would end up with a negative x over y. Okay, so that's your first derivative. All right, so now you need to take the second derivative. So I'll start my second derivative over here. Okay, so of this side, that would just be your notation that indicates your second derivative. Now, this is what you've got to take the derivative of next, and of course this will be implicitly, so this is going to require quotient rule. Now the negative, I'm just going to put that in front of my fraction here as I use my quotient rule. Okay, so this will be low low d high minus high d low. Now when you take the derivative of y, it is just 1, but then you have to do dy dx. And then that's over your denominator squared. Now, what you're going to have to do is when you do a second derivative, wherever you end up with dy dx, you have to replace dy dx with what it was equal to here. You have to replace that first derivative. So here, I have to replace with negative x over y. Of course, y times 1 would just be y minus x times negative x over y divided by y squared. Okay, so I have, well, let me go ahead and take one more step here and then I'll say what I was going to say. Of course, I can change this to addition. Okay, so now I have a complex fraction and the denominator I have here is y, so I just need to go through and multiply each of my terms in my fraction by that common denominator. So if I multiply this times y, I get y squared. And then I multiply, of course, this times y is going to give me x squared. Oop, I got ahead of myself here. That was supposed to still be a square. But then when I multiply it times that y, I get the y cubed. I said I was getting ahead of myself there. I'll tell you one other thing I just noticed that I left off was my negative here. So, I mean, that's easy to fix. Just transfer it down on each of these steps, just keeping it in front of the fraction there. All right, last thing that you could actually do on this one, going back to the original, you notice that you have x squared plus y squared equal 25. Of course, x squared plus y squared is what you have in your numerator. Of course, it's in reverse order, but it's still addition. It's the same thing. So you would actually be allowed to replace the numerator with just 25 because this states that those are equal to each other. So you would just have negative 25 over y cubed. Now, that last step of substitution that I did there is not something that you would always be able to do on every single problem. Okay, but this would be your second derivative doing it implicitly.